from your algebra days. Remember how to solve two equations at the same time? So we have x minus y equals 5, and no, plus, huh? And x plus y equals 5 and x minus y equals 1. Two letters, two equations. Remember something about that? How do we solve them at the same time? There's actually a few different methods. Yeah, there's the plug one into the other one thing, which is called substitution. Then there's the add them up, also called elimination method. Yeah, so this one I think is real nice for the add them up method, right? It's like ready to go, so I'll do that. I'm just going to add them, called the addition method. It's also addition or elimination method. It goes by both names because when you add them, they eliminate. So you add straight up and down, so vertically. So x plus x, just straight up and down, x plus x, 2x, good. And then positive y and negative y, just 0. So that's the eliminating right there. The y is eliminated, which is nice. And then 5 and 1, 6. We good to there? So it's nice when one of the letters drops out, because we can't really do two letters at the same time. We can only do one letter at a time. So we have 2x equals 6, and then it's cake, huh? Just divide by 2. X is 3. So that's the answer for x. How do we get y? Plug it in. And pretty much anywhere. Plug in x is 3. I'll just grab the first equation. You could do the second. It doesn't matter at all. Put in the 3. 3 plus y is 5. Subtract 3. Y is 2. So the answer is 3, 2. They want like ordered. Oh, I guess they want them separate, huh? X3, Y2. There we go. So that's what they want. Click option A, 3, 2, XY. There we go. Good. Remember all that? Little flash from the past there, right? All right. Do the easy ones and not get to the hard ones. That's always my tendency. All right. Let's just do it quick then. So what would you do first on this one, do you think? 3x is 30. It's a little different setup. X plus 2y is 0. There's a few different things you can do.
Solve for x in the top one.
Yeah, that's probably about the easiest thing, I think, too. You know, if you just took that x, you know, and since it's just got x, that top equation, you can just solve for x straight, huh? By that. So x is 10, and then just pop that into the other equation, huh? So you get 10 plus 2y is 0. Everybody get that? I just put the 10 in there for x. And then subtract 10. 2y is negative 10, divided by 2, y is negative 5. So yeah, that was pretty easy, right? All right, probably let's do that one. Okay, you want to try that one? So 2x plus y is 10, 6x plus 3y is 13. So go ahead and do the well, if we're going to do, you can do either method you want, really. I'm going to do the add them up thing again. In a minute, I'll do the plug them in thing. You can do that plug them in on this one if you want. Anyway, I'm going to do the add them up. So when you do the add them up, I don't want to add them right now, do I? Don't write this down. Let me add them right now. It won't work. Because you'd get 8x, 4y, right? 1y and 3y would make 4y. 23. That didn't work. What do I mean that didn't work? I added them. What's my problem? Nobody eliminated, huh? Remember, you want one of the letters to drop out. You want either the x's or the y's, it doesn't matter which one, to drop out, and nobody dropped out. So that's not good. That didn't work. So we don't really want to add them until we have opposites ready to go, huh? That's what was nice back here 2 problems ago. See how the y's, the first problem we did, they already started out as opposites? We had plus 1y and minus 1y, so they made 0 when we added them. They started out as opposites. That's rare. That won't usually be the case. So back to this one now, back to number 3. I got to make somebody opposites before I add them. Remember all that kind of stuff? So you could do x or y. Doesn't matter at all. I'll just focus on x. What can I do to that 2x to make it the opposite of 6x? Yeah, multiply the whole equation by negative 3. And then when that negative 3 goes boom, 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 that'll become minus 6x minus 3y minus 30. Then just bring down the other one, right? Which is 6x plus 3y is 13. And now add them up, and the x's cancel, 0. But so do the y's. We didn't really mean for that to happen, but it just also happened. The other thing is what? Minus 17? Anyway, so, right, so we made the x's opposites, but you had to multiply the whole equation, of course. Whenever you mess with an equation, you can go all the way across. Keep the equality by doing both sides. So anyway, I made the x's opposites, but lo and behold, I also made the y's opposites, not really even meaning to. So what does this mean? X and y have dropped out of the problem. What's that? It's no solution, yeah. Yeah, whenever you get 0 plus 0 equals a number where that number is not 0, right, it's no solution. That always means no solution. There is one other case. You guys know the other case? Remember it from your algebra days? What if you get 0 plus 0 equals 0? What's that mean? Yeah, dependent, infinite. Also, it's also called infinite solutions. Yeah, so if you happen to get 0 plus 0 equals 0, that's infinite solutions, also called a dependent system. That's true. Dependent system. I know people say it's not quite all real numbers. It's an infinite amount of answers, because they're really the same line. If you were to graph it, it means they're the same line right on top of each other. But it doesn't mean anything's an answer. It means anything on those two lines is an answer. So technically we say it's a kicky point, but technically it's infinite, not everything. Anyway, so everybody got those two main cases that are different? So 0 plus 0 equals a number right here. That means no solution. The way I remember it, no truth, no solution. So if you get like 0 plus 0 equals negative 17, that's not true. No solution. No truth, no solution. No, no. Whereas over here, 0 plus 0 does equal 0. It's kind of a simple truth, but it is true. And that's infinite solutions in that case.
It could be any number equal to itself.
What's that?
It could be any number equal to itself.
It really could. You're actually right. Yeah, so really it's whenever the thing's true. In any way. That's true, Robert. Yeah, good on that. Whoops, that didn't go anywhere. Okay, so try that one. 4x minus 4y. 4x minus 4y is 4. 5x plus y is 23. So you got to make somebody opposites, huh? Got to make either the two x's or the two y's be opposites. Which would be easier? The y's are a little bit easier because you could just multiply. Do you see what you could do for the y's? You could just take the bottom and multiply by 4, because that would make this plus 4y the opposite of minus 4y, huh? Now, you could do the x's. You'd have to make about 20, though, wouldn't you? You'd have to make one of them a negative 20, one of them a positive 20, and that's fine. You could totally do that. That's acceptable. But this would be easier. You only have to mess with one equation instead of both. Was the answer nice, or is it something weird?
Real nice. 4.
Oh, it's nice. X is 4.
4 and 3.
4 and 3, okay. And then divide by 24. X, that's 4 you said? 4? So x is 4, good. And now we just come back up here and plug in x. Well, you can plug in x is 4 anywhere you want. Doesn't matter. I'll just grab the first equation. Second one would work just as well. 4x minus 4y is 4. Plug in the 4. 4 times 4 minus 4y is 4. It's a lot of 4s. 16 minus 4y is 4. Subtract 16. Minus 4y is minus 12. Divide by minus 4y is 3. Yeah, sure enough, 4 and 3, huh? Good on that? 4 and 3? We good? All right, do y'all have your graphing calculators? Let me show you how to do this on graphing calculator. Oh, and we could have done that one by substitution. Now, you could have solved for y anyway. Maybe we'll do the next one by substitution. But anyway, let me show you how to do this one on graphing calculator. So if you have your graphing calculator, because that'll be helpful, especially when we get to the 3x3s here in a second. So if you have your graphing calculator, let me go to a fresh screen. We'll just redo this same problem. We already know the answer. So the answer is 4, 3. 4, 3, right? Not 3, 4? Yeah, 4, 3. 4, 3, x, y, 4, 3. So here's how you do it on your graphing calculator. I'll write out the steps and then we'll do it. So now I'm going to write the steps for a TI. Sorry, Thea. I have no idea how to do it on Casio. And those other, anybody else have a couple of you off Casio? So if you can figure it out, let me know, or hang out after class. I can go on YouTube with you and probably find it out real quick. Do you know how to, you know how to enter a matrix, right? You don't remember? I don't remember either. We did it a couple times, but, or I don't know if we did it. Anyway, I don't remember. All right, so here's the steps on the TI anyway. So on the TI, number 1, what do? Can I look at somebody's? I'll remember, thank you. Oh yeah, hit second matrix. So right above the, the x to the minus 1 key, hit second, the x to the minus 1 key, which is on the left side. Above it is the word, you're really getting the word matrix. You're going into matrix mode. So I'll put this, well, let me write it first and then I'll put it on the screen. So you hit that, it creates a matrix. When you hit that, you go into like a matrix world. And then you got to go across twice to the edit menu and hit enter. And then you got to give it the size. Now here's the matrix we're going to put into our calculator. Basically all those numbers. 4 minus 4, 4, 5, 1, 23. So everybody see what I'm doing? I'm just grabbing those. I'm just grabbing the 4 minus 4, 4, 5, 1. There's a 1 in front of the y there, right? 23, like that. That's what we're going to type in. So you got it. Now what's the size? Do you know how sizes of matrices go? Yeah, you go down and then across. It's the opposite of graphing. You know, graphing, it's always x first, sideways first, then up. It's opposite on matrices. So it's down 2, across 3. So that's a 2 by 3, and that order matters. You can't switch that. So the first thing it has you do is type in the size 2 by 3 matrix, and then enter the matrix. You know, meaning this matrix here. So then step 4, hit second mode, the mode key, which is in the top row, which really makes you quit, because it saved it. Basically, it's kind of like doing a word processing document. You know, you enter your document and save it and then exit. That's kind of what's happening. When you enter the matrix, every time you hit enter, 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 for every one. Here, let me put this on the overhead for a minute here now. Get out of the way. All right, so here I'll go back. So you hit second matrix. Here's the matrix key down here. So second matrix, boom. There's the matrix menu on the TI. Go across. I'm going to hit the right arrow twice over to the end. Yeah, there's 3 menus, which we'll use all 3 here. The first one is names. That's for naming a matrix, calling it forth. We'll do that at the end. The math menu, that's all the different math operations you can do on matrices. We'll do a few of those, especially tomorrow, because we're in the matrix chapter. And then over here, the edit menu. So that's where you enter the matrix. So that's what we want to edit, we want to enter one. So I'm on edit matrix A. So you could go down and put in B or C or D or whatever. I'm just going to stay on A. Edit matrix A. So hit enter. So now it's saying, that's the one I entered the other day when I was fooling around. This one's a 2 by 3. So I hit 2, enter, 3. So I'm hitting enter every time. 2, enter, 3, enter. Okay, now I just type in the numbers. What is it? 4, enter. I just type it in and hit enter. Now, remember, the negative is different than the subtract. It gets really bent out of shape when you reverse that, so watch out. Put in the negative, right? You guys know what I mean by the negative, right? Down here at this negative, down here at the bottom, right? So, all right, so -4, what else is there? 4, enter, 5, enter, 1, enter, 23, enter. So I just typed them all in and hit enter. Every time I hit enter, it saves it, saves it, saves it, saves it. So I can just turn off the calculator. It's got it saved as matrix A. In fact, I will now go second quit, second quit. We're out of that mode. Now what? So back to our thing. So now that we've done that, then you want to go back into the matrix mode. Second, x to the -1, which is the matrix. Go back into the matrix world. Step 6, go across to the math menu and go down to RREF, which stands for reduced row echelon form. We're not going to do, if you've studied before matrices with row operations, adding rows and multiplying that and replacing rows, that kind of stuff, that's what it's basically doing. I'm not going to go through all that. Feel free to come see me if you want to see that or talk about that. Math Excel will, if you want to hit the question help button, especially in the next section, you'll see all those steps, which you were avoiding. And you'll be so thankful for me as your teacher. It's not making you do all that. So, all right, go down to RREF and hit enter. And then let me see, what will it do? Then it'll call forth, let me make sure I'm telling you the truth here. Go down to RREF, which is way down off the list. There it is, like number B on mine anyway. RREF will come up on your screen, and then go back into the matrix mode again, second X inverse matrix. And you're on the right thing. You're on names menu already. So just hit enter. And then hit enter one more time and it'll do it. So there's the exact steps. Everybody got that down, and I'll show you. And you should get the answer. What you'll get on the screen will be 1001 with the answer to the right, 4, 3. Here's our answer. There's X and Y. Is that what you're getting on your screen? It solves it for you instantaneously. X is 4, Y is 3. The rest is an identity matrix. It's called, we'll get into that, especially tomorrow. Right, so let me go back. I'll go back. You guys got that copy down? I'll go back to here. Finish it up. So I'm going to hit, what was it? Second matrix. Go over to math, down to RREF. There it is. The double R. Reduce row echelon form. And then go back to, so it's saying, okay, you want me to do that math operation called reduce row echelon form. You want me to do that on what? It's asking me for what matrix I'm asking it to do it on. So then I go back to the matrix menu, second matrix, and I'm going to name one. I'm going to call forth matrix A, which is now has stored what I put in there. Hit enter. So it's saying reduce row echelon form matrix. You don't even need to close parentheses. Just hit enter. There it is. 4, 3 are the answers. Questions on that? But all good? So you can do these by calculator. 2x2s, I will ask you to also be able to do them by hand. Like there'll probably be a 2x2 on part 1 where you have no calculator. Part 2, we'll have the 3x3s. You can just do those by hand, by a calculator. I'll show you. We're about to get there. No questions on that one? We all good? Yes, let me just write out. 3x3s, calculator only. 2x2 must do by hand. So you do have to know how to do a 2x2, 2 letters, 2 equations, call that a 2x2, by hand on the test, like it could be on part 1. 3x3s I promise to not put on part 1. 3x3s you can just use your graphing calculator. I mean, you can do by hand if you really want to, if you kind of want to go through all that work. All right, so I'm going to put in the matrix, what is it, 1, -1. There's a 0 here, a 0 here, and a 0 here, huh? What's that? Oh, yeah, you're right. When I say this, you're right. It doesn't mean the size of the matrix. It means 3 equations, 3 letters. Yeah, you're right. I'm kind of confusing the issue, huh? Because the matrix ends up being 1 more. You're totally right. 0. Yeah, so that when I say that other 2x2, 3x3 thing, I mean, I don't mean the size of the matrix, because this is indeed a 3x4, isn't it, when you type it in? Yeah. I'm saying like equations, letters. So if I give you a 3 equation, 3 letter, you only have to do the calculator. If I give you 2 equation, 2 letter, you do have to know how to do those by hand with the elimination method. All right. Yeah, type that thing in and hit the buttons. And on the calculator. It's a 3x4 matrix, even though it's a 3 equations, 3 letters, it's a 3x4 matrix. So the calculator will do it. You'll get this identity. Identity means ones down the diagonal. See how you get ones down the diagonal, zeros everywhere else, and the answers on the right. What are the answers? Anybody got them? 4, 3. Is everybody else getting those for X, Y, and Z? 4, 3, 0. There they are. Is that good? Again, if you have a Casio or anybody else have, so there's Casio, anybody have like the high-powered TIs, like the Inspires or the, what's the other one, the 89s? You figured it out? You guys getting it going on the 89? No idea what I'm doing. Yeah? William, you getting it? Okay, you got it for that. It's probably, is that, I have no idea, but I'm glad to have come up after class. You know, I can go on YouTube if real quick. Same thing for the
Yeah, I got it.
Casio. You got it figured out? Who else said the Casio? She's got it if you want to check out class or come up. You got it? You got it too? Okay, yeah. If you're having trouble, come up after class. We can YouTube it. That's all I do. That's what I do for everything. Repairing my car, YouTube. All right. So there we go. Good? All right. So that's it. So again, calculator, 3x3 is just use calculator. 2x2 is by hand, at least on the test. You know, you can check with your calculator. Well, no, not if it's on part 1, huh? Word problems. All right, perimeter of a rectangular floor. So basically, they're going to give us word problems, and guess what they're going to become? 2 equations, 2 letters, or 3 equations, 3, probably 2 by 2. Probably 2 equations, 2 letters, because we're in the 2 equations, 2 letters section. So the word problems will go that way, usually. Perimeter of a rectangular floor is 180. So perimeter, you know, like if you have a rectangle, and you have width, and width, and length, and length. What's the perimeter formula? 2L plus 2W, remember that? Like if you want to go around, it's width and length and width and length is all the way around. 2 lengths and 2 widths added up. Area is L times W. We're not doing area right now. So perimeter is 2L plus 2W. And and the perimeter is, 180. So there's one equation. 180 equals 2L plus 2W. And then the length is 5 times what? The length is equals 5W. 5 times the width, huh? So there's my 2 equations with 2 letters. Make sense? 180 perimeter equals 2L plus 2W. And L equals 5 times W. So if you have 2 equations, you need 2 letters. We've got them. So what would be the easiest way to solve those? Yeah, I think that's a plug-in one. I'm going to do the substitution. That one's just asking for substitution because L's already alone, huh? L's already alone in one of the equations, so it's real nice to just say, look, L is 5W, which means wherever I see L, I'm allowed to replace it with 5W because it is 5W. It's equal to 5W, right? So just grab that, bless you, and pop it in right there in the L slot, huh? So that top equation will become 180 equals 2L plus 2W, but instead of the L, put in 5W, because that's what L is. Everybody see that? I just wrote out the top equation. 180 is 2L plus 2W, but in the L slot, I put the 5W. And the good thing now is I only have 1 letter. See how this equation only has W? I can handle 1 letter at a time. I just can't do 2. So now I can handle it. So let's solve it. So that's what 180 equals 10W plus 2W. 180 is 12W divided by 12. What is that? 16? 16? 15? 15. So W is 15. How do we get the L? Well, you plug into either one of these. The bottom one looks easier. L is 5W. So L is 5 times 15. L is, what's that, 75? Yeah. So the length is 75, the width is 15. We got it. That good? Seen all these in algebra, right? A little bit of review here. Try that one. Okay, so 62 total of 62 commercial and non-commercial. So I'm going to go, look, commercial plus non-commercial equals 62. Total of, add them up, right? Commercial and non-commercial. You could use X and Y if you want. I think it's easier to use meaningful letters. Whichever way's fine, though. In addition, so there's 2 letters, so you know what I need? 2 equations, right? The number of non-commercial was 2 more. Is it on the screen? Yeah. 2 more than 3 times the number of commercial. Can you write that equation? Non-commercial, 2 more than 3 times commercial.
3C plus 2.
Yeah. Right. Right. Yeah, right. Non-commercial was. Was is the past tense of is. And is equals. So that's my was or my is, right? Was means it was equal to, right? So non-commercial is equals 2 more, 2 added to 3 times commercial. And you could put it 3C plus 2, or, it doesn't matter what order you put that adding in. Whoops. Either way. Yeah, good. There's our 2 equations, right? What would be the easiest way to solve those equations? Yeah, the substitution again, I think, huh? Whenever one of the letters is already alone, I think plug it in is the easiest way to go. So just that bottom equation says n equals 2 plus 3c. So that means n is the same as 2 plus 3c, so you can replace n in the other equation with 2 plus 3c. So this goes in right there. So we get c plus n is 62, but instead of the n, I put in 2 plus 3c. That right there is the n, right? And now I have an equation with only 1 letter, so I can handle that. So c and 3c, what's 1c and 3c? 4c, right? Subtract 2. 4c is 60, divide by 4. C is 15. C is 15. Now we got to plug it in over here, I guess. C equals, or I guess n equals 2 plus 3c. You could have used the other one, doesn't matter. I'm going to plug in the c is 15, right there. Is that going to be 47? So non-commercial 47, commercial 15. Good on all that? Questions? Favorite kind of word problems did you have favorite kind of word problems in algebra? Mixture.
The ones that weren't word problems.
The non-word problems. All right, I'm going to show the standard way. I think it's about the best way to go. Beakers or buckets or whatever like. And the bottom go the percentages, or in this case the money is playing the role of the percentage. And in the top go the amounts. Right? This is a mixture. This is a mixture problem. We're mixing more expensive peanuts and cheaper, nuts. So cashews, which are more expensive, $4 a pound, with cheaper peanuts, $1.50 a pound. We're going to make an 80-pound mix of the two, and we want it to sell for $2 a pound. So it's going to be mostly what? Cashews or peanuts? Am I going too quick? Yeah, mostly peanuts. Everybody see that? Because it's closer to the peanut price, right? If we just made 80 pounds of pure peanuts, well, the peanuts are $1.50 a pound. It would sell for $1.50 a pound. If it was just peanuts. If it was just cashews, it would sell for $4 a pound. They're more expensive. We want to do a mix, but the mix ends up being pretty close to the peanut price, doesn't it? $2 a pound is pretty close to $1.50. So in other words, we know this mix is going to be mostly peanuts, isn't it? Mostly peanuts. So anyway, just good to have a general feel as we dive in. So how do we do the mixture one? So we have one bucket added to another bucket equaling the final product bucket, right, is over here. All right, put the percentages, or in this case, the money. So that'd be the $4, the $1.50, and the final product is $2. Yeah, the money is like the percentage. It's like the quality of the stuff. Sometimes they'll give mixture with acids. They'll say it's 70% acid or 30% acid or salt or something. Anyway, okay, so there's that. Now, what goes to the top? The amounts. Do we know any of the amount? Is there any other numbers in the problem I haven't put in my buckets, my beakers yet? The 80. Yeah, the 80 pounds. That's the mix, huh? So where does that go? Yeah, right over here at the end, because that's the final, this is the mix over here, isn't it? The final product mix. Does that make sense? So what do you think goes in this spot? And then we have to have an amount. So in every beaker or bucket, you have an amount and the type. An amount and the type, or the quality or the price. And an amount and the type. So what is the amount and the amount? Well, I don't know. Just call it C for cashews and P for peanuts. I don't know how many pounds of cashews. I don't know how many pounds of peanuts. Does that make sense there? All right, so now there's my diagram. How do I get if there's two letters, there are, C and P, right? Then you know I need two equations, don't I? How do you get your two equations? Equation number 1 goes right across the tops. C plus P equals 80. Top, top, top. That's just total pounds, huh? However many pounds of cashews, but however many pounds of peanuts must be 80 pounds total. And equation 2 comes from multiplying top and bottom. Multiply top and bottom. So that'd be 4 times C, 1.50 times P, and 2.0 times 80, which is really just 2 times 80, which is 160. Do you see what I did for that second equation? It was multiply, multiply, multiply. Top, bottom, top, bottom, top, bottom. Why? Why is that right to do? That's the total money, if you think about it. Because, remember, C is how many pounds of cashews, right? It's the amount of cashews times $4 per pound. Then this is the total monetary worth of all the cashews we're dumping in the mix, huh? Because it's however many pounds of cashews times $4 per pound. And this is P is how many pounds of peanuts times $1.50 per pound is the total monetary value of all the peanuts we're dumping in the bucket. And then over here, this is the total bucket's worth 160 bucks. How do I know? It's 80 pounds of a $2 per pound mix. So it must be worth 160 bucks. So cashew money, peanut money, total money. That's what that equation is. So there we go. 2 equations. Can I just go dot, dot, dot? At that point, you type it into your graphing calculator or whatever at that point to solve. Questions on getting to the mixture equations? Everybody got it copied down? All right. What formula do we always use on a travel problem? Yeah, distance equals rate times time. I had a student used to call it the dirt equation. That works. That helps you remember. It looks like the word dirt. So, okay. Now, what are we talking about in this problem? Well, we've got a couple airplanes. One of them can fly 420 miles in 2 hours, and the other one, same distance in 3 hours against the wind. It's with the wind or against the wind is what we're talking about. Now, what's that going to do? I think you know naturally. What if you're with the wind? If you're flying with the wind, let's say the plane can do, I don't know, let me just make up a number, 200 miles per hour on its own, and the wind is blowing at 30 miles an hour. So if the plane can do 200 and the wind's blowing at 30, how fast will the plane go when it's with the wind? Yeah, you just add. It'd be 230, huh? What about when it's against the wind? What's going to happen? It's just going to subtract, of course, right? So in other words, it's going to be plane plus the wind when you're with it, and it's going to be plane minus the wind when you're against it, isn't it? And which boxes, if I put dots in those 6 boxes, which 2 boxes will this go and this go? Are these rates or distances or times? They're rates. They're speeds. They're how fast, huh? This is 230 miles an hour. It's a speed. It's a rate, right? Rate is speed. So basically what I'm saying, that's a long way to say that right away you want to put plane plus wind and plane minus wind in the rate boxes because that's how fast. It goes in the plus is the width, and the minus is the against the wind. Remember these from your algebra days? So the plus rate is when you're with the wind. The minus rate is against the wind. There's my two letters, right? P and W. Okay, so what now? Let's try to put the rest of the facts into the table if we can. So what does it say? 420 miles in 2 hours. That's with the wind. So with the wind, 420 miles. 420 miles, is that a distance, rate, or time? 420 miles is the distance width. See how that's the distance width box there? And 2 hours is the time width, huh? And then the second part says, against this same wind, same distance, of course it's the same distance, it's a return trip, huh? Same distance, but it takes it 3 hours, the time against the wind. Okay, so that's a nice little diagram and everything, but I need to get a couple of equations out of that thing, right? 2 letters, I need 2 equations. So, do you see what they are, though? It's the D box equal to the R box times the T box. Huh? So, it's 420 equals P plus W times 2, and 420 is P minus W times 3. Everybody see that? Distance equals rate times time. So there's our 2 equations with 2 letters. What would be a good first step for solving those? You could distribute, and that's what I did yesterday when I solved it with the other group. But then somebody said afterwards, shouldn't you just have divided? And I thought, oh yeah, that would have been even better. Yeah, if you just divide by that 2 right away, it's kind of nice. You get 210 is P plus W. And if you take the other equation, 420 is P minus W times 3, and divide by the 3 right away, was that 140? P minus W. So then bring this one down here. 210 is P plus W. See how nice that is? Kind of coincidentally turns out really nice. Because then the W's cancel when we do the addition method. 2P, what is this? 350 divided by 2. Got our hands on P already. What's that? 151.75? The plane's going 175 miles an hour. And we could find the wind, just plug in. Good on all that? Bless you.
Thank you.
So there is travel. All right, so basically we have this whole new world, whole new things we're making up called matrices. And that is the right word to use. We're making it up. We're not, but somebody else just made it up. They said, hey, what if we put like numbers in boxes? What could we do with that? I mean, well, it wasn't quite like that. You can look it up on Google. I think it was, somebody was trying to figure out a way for mixing, I think it was alcoholic beverages. I think it was beer or something like that in a factory, and they were trying to do I might have that wrong. You can type into Google and find out. It was something like that was the first use of matrix, 1800s or something, I think, 1700s. I don't know. Anyway, feel free to look it up. But for some reason, like some real life practical thing they were trying to do, they realized it would be convenient to put numbers in boxes and have them represent something real and do stuff with them. So they put numbers in boxes and they said, hey, we got to make up a way to add, subtract, multiply, and divide these numbers in boxes called matrices. And they really did do just that. They made up ways to add, subtract, multiply, and divide. And they did the adding, subtracting, I think like any of us would, and they made the multiplying and dividing really, really strange, which most people would not have done it that way. So we'll see what they made up. Remember, math is made up to describe things that are real, right? All right, so how if it was up to you, and it was your job to say, hey, how do you think we should subtract these numbers in boxes, these matrices? What should we do? What would you do? What would be the rule? Should we like add all these up? What is that? 6, 8 minus 1. This is a big 7. Add all these up. The answer is no, you can tell. 6 minus 7. Was that -4 and then just add those? The answer is 3. No, nobody would think of doing it that way. It's a good thing they didn't. That's craziness. You might not even know what I even did there. Don't worry about it. I just added up all those numbers. But that's not what you do. What do you do? Yeah, number by number, right? Just corresponding. That's exactly the rule. You just say, look, upper left with upper left. 0 and 4, 4. Upper middle, 2 and 1, 3. Upper right, negative 1 and 0, negative 1. This is exactly what they did, just totally natural. Lower left, what's that? Negative 7. Middle, lower middle, 2. Lower right, 2. 2, yeah, 2. And there we go. If I do something bad? Oh, we're supposed to subtract. What am I doing? It's not an adding problem? Well, messed that all up. All right, let's try again. We're supposed to subtract. So 0, take away 4. Negative 4. 2, take away 1. 1. Negative 1, take away 0. Negative 1. Good so far? Now it's right, huh? Lower left 1, take away. So 1, take away negative 8. It's going to be 1 plus 8. It's going to be 9 down here, huh? Right? And then 1, take away 1. That's a 0. 4, take away negative 2 is 4 plus 2 is 6. There we go. Yeah, just entry by entry. Totally natural, huh? That's what you and I would have come up with, and that's what they did. Just entry by entry. Is that good? All right, that's exactly what they did. Talk about how do you take a matrix, a box with numbers in it, and multiply it by a number. What does it mean to take 3 times matrix B, which is 4, 1, 0, negative 6, 1, negative 4? What does it mean to put like a 3, see over here, a 3 in front of a matrix? What would you do? Multiply all the numbers by 3. It's exactly what they do. Boom, 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 boom. It's just a big old distribution. Becomes 12, 3, 0, minus 18, 3, negative 12. Just multiply them all by that. That's it. Pretty simple, right? How do you add matrices that are different sizes? See how these are the same size, so that one's real natural. But let me ask this question. What if matrix, let's say C is, 1, 2, 3, 4, and matrix D is 5, 6, 7, 8, 9, 10. It's different size, you know. How do you add matrix C plus D then? What about different size matrices? We've just been adding and subtracting the same size. What's the deal? What do you do with, what would you make up? And then I'll tell you what they made up. What would you make up for adding different size? How do you add different size matrices? Anybody got an idea? Here's some zero talk. Put like zeros over here to make, fill in zeros wherever the other one has stuff that you don't, and do it that. They could have done it that way. They didn't do it that way.
Add 1 and 2.
Add what?
Add the first row.
Add what's missing as
Like how it's 1 and 2, just add 1 and 2, so it's 3 on the third row.
Oh, just add them and then put that over here like a 3. Add them.
Add the sum of all of the whole row? Or that one?
Yeah, that's what he's saying too. Just put that in that spot and then 3 and 4. They could have, but they didn't. You know what what's that? That's what they did. They said, don't do that. That's what they said. No. They said no. Sometimes you just say no. Yeah. They said, don't ever do that. They couldn't see any real life use for that, of adding different size matrices. So the answer is we never do that. Now, it'll be different for multiplying tomorrow. We will multiply matrices that are different sizes, and we'll do it really weird. But that's for tomorrow. All right, guys, have a good day. So this 11.1 is due tomorrow.